sorry about that. We are back to the dimensional analysis converting units. And we were just going to do a problem with an RC car, and it says it travels at the rate of 10 feet per second. So step one is just write the beginning info as a rate or a fraction. And so that is 10 feet. It's super important to write your units when we're doing this. 10 feet in per second, which means 1 second. Okay, step two is figure out what needs to change. It asks us how many inches per second is this. So we want it to be, we have to change, so per second stays the same. We just have to change feet to inches. So then you think to yourself, in the book there are charts, conversion charts to help. I'll put pictures of them on the canvas as well. And then some, they just kind of expect you that you know. Like, you know, seconds and minutes and things. Okay? So what we need to do, we want to change feet to inches. So the relationship of feet to inches, hopefully you know that, is there are 12 inches in 1 foot. Okay? So this is another fraction we're going to write next to this fraction. But we can write it either way. We could either put the inches on top and feet on the bottom, or the feet on top and inches on bottom, depending on what we want to cancel out. Right now we've got feet on top, and we want the feet to cancel out because we want to change it to inches. So that means if we've got 1 on top, we need to have 1 on bottom so they cancel out. So I'm going to write this fraction with the feet on the bottom and the inches on top. And then just like with our cross canceling or pre-simplifying, if you have 1 on top and 1 on the bottom, they cancel out. And now we have inches per second. So these are fractions that we're going to multiply together. Now it's called, the dimensional analysis is usually called the picket fence method because I like to write it like that and kind of put them in different, because we can do this, like we can fill an entire paper worth of conversions to change things. And so it just keeps them super organized, okay? So these are fractions that we multiply together. So 10 times 12 is 120. And we keep the inches in 1 second. Okay? Now, if we wanted to, we could do a second conversion and find out, instead of changing from feet per second to inches per second, we could do inches per minute if we wanted to. So let's see if we can change the seconds to minutes. So let's think about that for a second. There are 60 seconds in 1 minute. Okay, so we're going to write this as a fraction, but this time we want the seconds to cancel out. We have seconds in the bottom here, so we're going to put the seconds in the top over 1 minute, and then we can multiply these fractions together. So we're still, the seconds cancel out because we have 1 on top and 1 on bottom, so we've got minutes, and then we're going to do 120 times 60, which is 7,200 inches in 1 minute. Okay, so that's the picket fence method or dimensional analysis to keep these things organized. Let's do a couple more practice problems, just hopefully that'll help you feel a little bit more comfortable with it. Let's see. Marvin walks at a speed of 7 feet per second. So that's our first fraction. So we've got 7 feet per 1 second. Okay, how many feet per hour is this? So this time we're going to leave feet where it is, and we're going to change seconds to hours, but that's going to take 2 steps. Okay, so first we're going to change seconds to minutes, and I am going to picket fence it this time because I want to put all of my fractions together first, and then we'll multiply them together. So to change seconds to minutes, just like we have over here, it's 60 seconds in 1 minute. And again, we've got seconds in the bottom right now, so we're going to put the 60 seconds of that fraction up top so that the seconds will cancel out. Okay, but are we to hours yet? Nope, we got to keep going. So again, there's now 60 minutes in an hour, and those are all thanks to the Babylonians, if you remember from our ancient number systems. And so it's same idea. We're going to put the 60 minutes up top and 1 hour on the bottom so that the minutes cancel out. Okay, so just looking at our units, we are left with feet and hours, which is what the problem asked us for. Okay, now we're going to multiply across. The bottom is just 1 times 1 times 1. That's awfully convenient. The top is going to be 7 times 60 times 60, which is 25,200 feet. Now, what I think would be useful in this problem was instead of stopping at feet, let's actually change it to miles per hour. Okay, because that one actually make it a useful rate that we would know. So to change feet to miles, this is a good conversion factor to just know there is 5,280 feet in a mile. That will be on one of the charts that I put up. So feet, we have a feet on top, so we need to put feet on the bottom. 5,280 feet to 1 mile. And then if we multiply those across, it's just 1 time, so they end up being on top of each other. 25,200 feet over 5,280. Okay, it's not feet because we just canceled the feet out. Thank you. So feet and feet cancel out, so we've got miles and hours. And then let's actually do this division so it's a useful bit of information. So I'm going to do the 25,200 divided by 5280. And we find out he is walking 4.77 miles per hour. And that's a rate that I actually can recognize and do something with. So there you go. That's the basic idea. Let's do, I have one more practice problem I wanted to do. Woohoo! But that's the one right there. So it says waterways, and these are just practice problems out of the book, so you're welcome to look at the book and go over some extra practice problems. This one's actually from the guided practice section. And so it says water weighs about 8.34 pounds per gallon. So that's our starting rate, 8.34 pounds per gallon, which means 1 gallon. And then it asks how many ounces per gallon is the weight of the water. Ounces per gallon. So the gallons are going to stay. All we have to do is change pounds to ounces. Again, this will be on your conversion rate chart, knowing what the unit rate is for converting that. Maybe it's, oh no, it was there, 16. So it's 16 ounces to 1 pound. And the more you get into like cooking and baking and stuff, that's a number that you actually learn to know. So 16 ounces in 1 pound. So then the question is, we've got pounds up top. Where are we going to put pounds in the second fraction? We're going to want to put the pounds in the bottom so that they cancel out. So 1 pound and 16 ounces. So the pounds cancel out, and we multiply our fractions across. The bottom, luckily, stays 1 gallon. And then the top, we do 8.34 times 16 ounces, and we get 133.44 ounces per gallon is how much the water weighs. Okay, so that's the basic idea on that. There's just a few problems to try for dimensional analysis, few problems for the complex fractions, and then we'll be good to go.